system internship project which I completed through MRG Information Technology. The title of my project is microcontroller based microwave oven system implemented using the PIC16F877A microcontroller. In this presentation, I will explain what I learned during this internship, the project requirement, design, implementation, tools used, and finally demo of the project. So let's start. So first of all, I gave my brief introduction to you. So my name is Sagar Mohanty. I am a pre-final year student of electronics and communication engineering. I have a strong interest in embedded system and microcontroller based application, especially understanding how hardware and software work together in a real-time system. As part of my learning journey, I completed a 1 month embedded system internship from MRG Information Technology, where I worked on a practical embedded project and strengthened my fundamental in embedded C and microcontroller skills in embedded system engineering. In this presentation, I will be explaining my internship learning and the project that I implemented during this period. So let's just start. So I gave you here the brief internship overview here. So this internship was conducted by MRG Information Technology in this domain of embedded system design, and it was a 1 month online internship conducted through structured video lectures, LMS content, live sessions, and practical assignments, and the project based learning and some tests after the embedded C classes and microcontroller classes. There will be 3 tests I was gave in recent in this internship. So this internship focused on the theoretical concept and hands-on project implementation, which helped in understanding how embedded systems are developed in the real-world application. So next slide here I discuss about the goal of this internship. The main goal of the internship was to develop a strong foundation knowledge in embedded systems design. It aimed to improve our understanding of embedded C programming, microcontroller architecture, and hardware-software interaction in embedded system design solutions. Another important goal is to gain practical exposure by implementing a real-time project that I built here, a microcontroller-based microwave oven system by a microcontroller PIC16F877A by MICROCHIP, and here which bridges the gap between academic learning and industry requirements. So back to the next slide. Here I will discuss about the internship structure. The internship was divided into multiple phases. In the first week, I learned embedded C programming from basic to advanced, which is mandatory to learn how the pointer will work, how the strings will work in embedded system and programming, and how the um, various concept data types works in embedded system programming. All those things followed by an assignment test. I gave you the practical what I learned this 1 week embedded C classes. In the second week, we learned embedded system concept and microcontroller fundamentals. In the third week also embedded system concept and with test. And the last fourth week, I focused on the project development implementation and testing classes. So these 4 weeks I learned these many kinds of things in this internship. So back to the next slide. So here I'll explain what I learned, what is embedded C programming. So embedded C programming is used to program microcontroller by directly interacting with hardware register. And during the internship, I learned about data types, control structures, functions, pointers, strings, and bit level programming, environmental programming of the embedded system. All those things I learned here. Special focus was given to register manipulation, timers, interrupts, how to program a microcontroller, how to program a CLCD, how to program a timer, how to program a switch, how to program a microcontroller based application system, which are essential for the real-time embedded application. So back to the next slide, what I learned next thing. So here I will explain what I learned, what is an embedded system. An embedded system is a combination of hardware and software that perform a specific function with some mechanical part. So embedded system is a dedicated for embedded system is a system that works and performs a dedicated function. So just I gave an example like a washing machine, microwave oven, AC air conditioner, and all those things that undergoes under the embedded system. Unlike general purpose computers, embedded systems are dedicated, resource constrained, and often operate in a real-time environments. So examples I gave before: washing machine, microwave ovens, automobiles, and medical diagnosis devices are the example of embedded system. So back to the next slide. Here I gave you microcontroller overview that I learned this internship. A microcontroller is a compact integrated circuit that contains a CPU, memory, and peripherals on a single chip. Like a microcontroller, we learned in our college's syllabus, like 8085, 8086, 8051 microcontroller, all those things. 8051, 8279, 80386 microcontroller, all those things we have learned in our college's syllabus. Here I discuss about microcontroller used in our project. In this project, I used the PIC16F877A microcontroller, which is a 8-bit microcontroller from MICROCHIP Company. It is a commonly used for educational and some practical industrial application due to the simplicity and availability of peripherals, and it is easy to program uh, through embedded C programming, any kind of compiler and IDE, the best development environment. So it supports multiple input output ports and external interfacing systems in this microcontroller. It is a 40 pins and 8-bit microcontroller we have used in this project. Back to the next slide. Here I will discuss about the features of a PIC16F8A77A microcontroller. The PIC16F8A77A microcontroller follows the RISC architecture, reduced instruction set architecture, set an architecture which improve execution speed in this microcontroller. So it includes built-in peripherals such as timers, DC, analog digital communication, and interrupts and serial communication modules. These features make it suitable for developing real-time embedded system application like our project microcontroller based microwave oven system that I build here. So let me give a project overview here. My project is implemented during this internship with microcontroller based, as we know, it is a microwave oven system. This system simulates the working of a microwave oven with a menu-driven interface in a CLCD platform. User can select different modes, operating modes, and interact with the system using keypad and CLCD display. So here I give you the project objective here. The objective of the project was to simulate the basic functionality of a microwave oven. It allows the user to select different modules and modes such as microwave, grill, convection mode, start, preheating mode. mm, all those four modes I implemented in this project. The project also focuses on real-time user interaction and time-based controlling using timer, because whenever we select a function like a grill mode, suppose a grill mode we as user select, then user give the certain time to make a grill application in this project. That function in the CLCD display that shows how time is counting, timer is started in CLCD display that show how the function is work. So let me give you next slide. Here is the block diagram of a PIC16F8877 microcontroller. Here is the 40 pins you can see here. So all those things here are in read pin. It's and it is a VDD here, the power source provided through this pin VDD and VSS. So all those things here, VDD VSS also in here 31 and 32, and here 11 and 12 pin. And here is the block diagram of a 16:4 CLCD display block diagram here. And here is the block diagram of a 4 into matrix keypad, 4 into 4, 4 plus 4 matrix keypad here. Matrix keypad is used to input a character LCD used to for output display. So timers are used for managing the cooking time and the system control. The hardware components I have used in this project, the major hardware components used in this project include the PIC microcontroller, PIC16F877A microcontroller. The major components used in this project including PIC microcontroller, keypad and LCD display. These components work together to provide user input of processing and output display. The system was designed to simulate real-time microwave oven functionality here. So back to the next slide. Here I discuss about the software tools I used in this project. So here I used three software tools that is given here: MPLab XIDE, XC8 compiler, and PiximLab. So let me elaborate all three software tools here. So MPLab XID was used here to write program and compile the embedded C code here. So the XC8 compiler was used to generate the hex file of the code that I used in the simulation of the project. So simulation was done through PiximLab simulator, the hardware environment, and the verify the project functionality using through the hex file code which was generated uh, which is generated through XC8 compiler. So now I discuss about the development process of this project. The development process of the project was fully designed and discussed about all the process, development process and requirement as analysis by Emergy. So then the system was designed and coded using the embedded C through MPLab XIDE and compiled, and also the generate the hex file through the XC8 compiler, which was done by the project implementation classes by Emergy. And the project was tested through the simulator, which is PiximLab simulator, and all the errors what I challenges we faced during the program and code the embedded C for this project. All those things I discuss later. So here error were debugged and corrected during the developing the code and project also. So back to the next slide. So menu screen design. The system starts with power on screen followed by the menu screen. Whenever we start the simulation of this project, it shows the star power on screen on LCD display. When I start the simulation, the microphone starts a animation, giving animation like power on microwave oven like this, and followed by a menu screen. There are four modes that I discuss later, and user can select those mode through the keypad what they need to functioning through this simulation. The LCD provides the real-time feedback and instruction to the user what the function is need to do by the microwave oven. So then back to the next slide. Here the implementation details is given here. So the project implementation involves a keypad based input and LCD based output. Whenever user presses the keypad for across four keypad as per the four mode is given in this project, that is grill mode, convection mode, preheat mode and start mode. So four modes are provided as per the user requirement. Input the need of the input more, and then the output is implemented through the LCD based output. LCD display. And the timer and the interrupts are used to manage the time-based operation that give real-time scenario of this project. So proper state management ensure the smooth transition between the modes. So that's why we used 20 to 30 or 32 megahertz speed during the simulation to ensure the smooth transition and the smooth functioning of the simulation. So here I gave you project demo. So let's go to the screen of our MP Lab XID. Then we see the project code, all those things here, and also the simulation of the project that I built in this project session. That is nothing but a microcontroller based micro system, again I repeat here. So how the simulation was observed, the slides shows the simulation of the project. We can observe mode selection, time setting, and the system response, all those things there. And the simulation verifies that project works as expected. So let's go to the Pixim Lab simulator to showcase our show the project simulation. So as we see there how the simulation of our project is done, and let's discuss about the next slide. So here I discussed what challenges, which type of challenges I have faced during this internship and project development. During this project development, challenges were faced in debugging the logic errors and timer handling and error detection and um, clean and build errors, all those bug discussion. These challenges helps to improve my understanding of the embedded system design. Problem solving and debugging skill were significantly enhanced here. So back to the next slide. So here I discuss about the learning outcome of the internship. This internship helped me gain strong fundamentals in embedded C programming. I learned how to interface hardware component and design the real-time systems here. It also improved my confidence in the working with microcontroller programming and microcontroller based project building using the embedded system design system real-time embedded systems. So as per the conclusion here, in conclusion, this internship provided valuable practical exposure in the embedded system design. It helped to bridge the gap between the theory and the practical implementation of all the designing and the practical exposure, industry relevant skills, and project based training. All those things I have learned here. I would like to many thanks to Emerging Information Technology for this learning opportunity and select me for this internship to expose the and having skill learning skill from this internship training. So thank you for this internship. So I'll conclude here. So thank you.